Okay, so these are notes for elimination. So how to solve a system using the elimination method. And the word elimination just means that you're going to eliminate one of the variables. And the easiest thing to do is always to eliminate the x, but sometimes you can just add up. So in example number 1, if I just kind of look at this and I just look and I'm going to add these two equations. So when I go through and I'm going to add those two equations, x plus y equals 7 and 2x minus y, so when I add those up and I add those two equations, what happens is those y's are going to become eliminated because 1y minus 1y, oops, that should be a minus, sorry, so y minus 1y, that is now those x's, when you add those up, when you combine them, that will just be 0. So what I'm meaning is, so this would be 3x, because 1x plus 2x is 3x, and then I just add those up. So y plus minus y cancels out, and then I get 7 plus 2 is 9. So all I did was I added that because the y variable, that y variable becomes eliminated. Hence, that elimination method is used. So now we just go through and solve for x. So we've got 3x equals 9. I'm going to divide by 3 on both sides of the equal sign. So then we just end up getting x to be 9 divided by 3 is 3. And now I'm going to substitute that in. Now, it doesn't matter. I'm going to substitute that x in because this is where I'm at, this next little thing. I'm going to substitute that x value into one of my equations. And I go back and I look at my two equations at the very, very top. And I look up here and I say, okay, which equation looks a lot easier? I'm going to use that top equation here. It looks a lot easier to do. X plus y equals 7. So now, in order to do this, I'm going to have x is now 3. So I'm going to use x plus y equals 7. And now I'm going to have x is 3. And then I have plus y equals 7. And now I've got to go through and solve for that. So again, I ran out of a little room. So 3 plus y equals 7. And I'm going to subtract 3 on both sides. So 3 minus 3 cancels out. And now I have y is equal to 7 minus 3 is 4. So I went, I've already done that. Now I solve for y, it's already there. So y is equal to 4. Sorry, I already did the math. And then that solution point ends up being 3, 4. And notice that that's inside my parentheses. And then it's always a good idea to go through and check. So I'm going to say, okay, 3 plus 4, does that really equal 7? And 7 is equal to 7, so this is okay. That's good. And then this one, 2 times 3 minus 4, does that really equal 2? So all I did here was I substituted 4 in for y, and then I substituted 3 in for x. So I substituted the x and then the y, and then I'm going to go through and then we're going to do some math. So 2 times 3 is 6 minus 4. Does that really equal 2? Yep, 2 is equal to 2, so we're okay. We did it correctly. And again, instead of doing this work, you would probably use Desmos because it would take a lot less time. But this is how you do it algebraically. If I say to check algebraically, or if a state test says to check algebraically, that's what you do. But in real life, use Desmos. It makes your life much easier. Okay. So this one is now example 2 says, this time you're going to understand the equivalent systems of equations. And I missed... So, and then there's a typo in my notes, and I'm sorry. This should be a plus. Sorry, that's me. X plus 3y equals 7. So this is exactly the same thing. So now when you go to Desmos, it should just type that in, and you should have the exact same graphs. So if you type this in, 2 Desmos, x plus 3y equals 7. Type that in. So we've got x plus 3y. Whoops, I lost my little thing. Plus y equals 7. And then I just type that in, and now I've got my graph. So now when I go back and it says, okay, now let's see when I have, oh, and it should be 3y equals 7. Whoops. So this should be a 3y. I forgot my 3. Sorry, guys. So this is your original equation. Now what happens, let's see when I go through, and I'm going to say, I'm going to multiply this by -2. I'm going to multiply that whole thing. So I'm going to put parentheses around the whole entire equation. So it should be x plus 3y, and then equals 7. And then you go through and you close your parentheses. Whoops. Might have to close parentheses here, and then just go, oh, -2 there, because I don't think Desmos recognizes it. I've got too many little, there we go. So, I got rid of my 2 there. Whoops. There we go. So notice, there's my original line. It is red. And then my blue line, when I go on top, they're equivalent to each other. So the only thing that I really want you to see with this is just when you multiply both sides of the equal sign by the same number, it still gives you that equivalent equation. So that's why you can multiply, because it ends up being that equivalent equation. Now I'm going to go back to my notes. And now when we're back to our notes, how many lines did you see on the graph? Oh, there was only one line. So there was one line, and how do you use multiplying would be helpful to solving a system. So that whole idea with multiplying to solve a system is because it's just going to help eliminate a variable. And remember that eliminate just means that you're going to get rid of it. It's just going to go away when you add up equations. So now we're going to try this when you have to eliminate. So we've got this example number 3. And I go through and I watch my little notes that I give you on the right-hand side, because I went through and I kind of wrote those. So you're given this. What number, so this is like, what number should you multiply to the equation to eliminate that x value? So what I like to do, think about this. You think about the coefficients in front of those x's, and I just highlighted both of those yellow. So that coefficient in front there, this is the same thing as saying 1x. So 1x plus 3y equals 7, and 2x plus 2y equals 6. So that when you add these are going to become eliminated. So and you have to think, so this is what I do. The bottom is 2. The top is 1. So what I do is I go through, and when I go through and multiply, I'm going to write my equation. So x plus 3y equals 7, and 2x plus 2y equals 6. All I did was rewrite my equations. So, and I'm going to put the 1 in front of that x so you can actually see it. Now, here's the thing. This 1 is going to be moved down here. And then this 2 is going to get moved up there. So what is now on the bottom gets moved to the top, and what's now on the top gets moved to the bottom. And so those coefficients of x, those are the numbers in front of x. Now the problem is 2 times 1 is 2. 1 times 2 is 2. And 2 plus 2 is 4. I want that to become eliminated, so I'm going to make one of these negative. And if I make the top negative, if I just make that top negative, then I don't have to do anything to that bottom equation. So now that bottom equation is just 2x plus 2y equals 6. I didn't do anything to it. It's exactly, and that's a 6, by the way. And so now this top equation, I got to go through and I've got to distribute that whole thing by -2. So -2 times 1 is -2x. -2 times 3 is -6y. And -2 times 7 ends up being -14. So now we've got to go through and now we've got to add these up. I'm going to add my two little equations up. So -2x plus 2x becomes eliminated. And I have -6y. So I've got -6y plus 2y is -4y. And then I have -14 plus 6. And then this will end up being -14 plus 6 is -8. And notice that that's when my x became eliminated. So before I move on, this is where in a Zoom, you're going to have to ask questions because it's going to be, you're always going to take your two coefficients to x, and those are your numbers in front of x, and you're going to flip them. And then one of them needs to be the opposite sign. So now this time we have to divide, well, now we're going to solve for y, so I'm going to divide by -4. So now y is equal to 2. And now I go through. So y is 2. This side, substitute the y value into one of your equations. I like to pick my easiest equation, and the one that seems easiest to me is the first one because it's a 1x. And then I wouldn't have to go through and divide. So I'm going to have x plus 3y is equal to 7. And now I'm going to go through and we're going to take that 2 and I'm going to substitute it in. So I'm going to have x plus 3 times and then equals 7. And now I'm going to substitute in that 2 in for y. So when I go through and do this, I've got x plus, and then 3 times 2. 3 times 2 is 6. And then this equals 7. So now I've got this. So now I've got x plus 6 equals 7, and I'm going to subtract 6. That's a 7, by the way. And that cancels out. So x is equal to 7 minus 6 is 1. So my solution point, remember my solution point has parentheses. I'm going to have parentheses. X is 1 and y is 2. So 1 comma 2, close your parentheses. And then we go through and check. And again, let's just go and look and do it there. I'm going to show you algebraically, but then I'll show you how to do it in Desmos again. So I'm going to have 2 times 1 plus 2 times 2. Does that really equal 6? And that's a little question mark above the equal sign. So 2 times 1 is 2, and 2 times 2 is 4. So 4 is equal to 6, so 6 is equal to 6. This is true. So we're golden. It's good. It's okay. It's correct. So the next one, I have 1 plus 3, and y is 2 times 2. And then this equals, I don't know why it's going to make a plus. This equals, does that really equal 7? So you say 3 times 2 is 6, plus 1 is 7. So 1 plus 6 is 7 is equal to 7. Yes, this is true. We did it right. It's okay. Any one of those. So this is how you would check it. You would also check, you can use Desmos. So I would have 1x plus 3y. So I've got this here. And then I would have 2x plus, I gotta go back, 2y equals 6. Plus 2y equals 6. And then I look at my point of intersection there, and my x value is 1 and my y value is 2, so I know I got it correct. Honestly, this is the real life way that I would actually check it using Desmos, not doing it algebraically. That's how I had to do it because I didn't have the fancy calculators. I had to do it the old-fashioned way. I had to do it this way of checking when I was in high school. Not fun. Okay. So now, let's see if you can do this. Which equation should you multiply by what number? So I want you to think about this. Which equation should you multiply? This is the only part I want you to do, and I want you to think about it. So that means that you're pausing the video and you're actually trying this on your own. So let's see if you get the same thing. Okay, so you should have tried this and you should have thought, oh yeah, the 1 goes on the bottom. So this 1 is on the top, it moved to the bottom. This 2 went to the top. So these coefficients of x, those numbers in front of x, just flip. And then they're both positive, so I'm going to make 1 negative. And it doesn't really matter which one you make negative, but I just like to make one of them negative. So now you've got, and now I go through and I'm going to distribute. I go through and I distribute that whole thing, that whole equation by -2. I have to multiply -2 by everything on that top equation. So I have -2x and then minus 4y equals -8. And then that bottom equation just stayed pretty much the same because multiplying by 1 is the same. So you have 2x minus 5y equals -1. And then we go through. So I've done the multiplication. So now we go through and we're going to add our equations. So -2x plus 2x, the x's became eliminated. And in this distance learning, I'm teaching you how to eliminate the x at all times because you'll never go wrong. You might have to do a little bit more work, but you'll never go wrong. So -4y minus 5y is -9y is equal to 8. -8 minus 1 is -9. So now I solve for y because I'm going to divide by -9. So now y ends up being, because that cancels out, and this ends up being +1. So now my y value is 1. So now we got to go through. Now remember, that's 3/4 of my problem. I've just done 3/4 of it. I'm going to go through and I'm going to multiply. I'm going to solve for x. And I like to see which one of these looks easier. Again, this top equation looks a little bit easier, so I'm going to do that. So I'm going to have x plus 2 times 1 equals 4. So 2 times 1 is 2 equals 4, and then I've got x plus. Then I'm going to subtract 2 because I got to solve for x. So this whole thing, once you find y, you got to go through, plug it in, and I plugged it into my top equation there. And I plugged y in, my y of 1, in for y. And now I just go through and solve. So x is equal to 2. And that should have been your answer. So now go through this time. I'm going to move my pen over. So which equation on the next one do you think you're going to do? Let's go through and try that one. This one's a little bit harder because I flipped around a little, so pay attention. So again, on this one, you're going to go through this one. My top equation is 1. I multiply that coefficient. That top one is 1. And then the bottom, I multiply by the opposite of +2, which is -2. So then when we go through, now we're going to rewrite it. So that top equation doesn't change. I get 2x plus y equals 2. And then that bottom equation, I have to distribute that -2 throughout. So -2 times 1 is negative 2x. And negative 2 times negative 2y is plus 2y. And negative 2 times negative 5 is positive 10. So now we're going to add. So I've multiplied out. I've multiplied my equations. So now I'm going to add my two equations together. 2x minus 2x cancels out the x's. The x's became eliminated. And remember that if there's no number in front of a letter, then that number is 1. So I have 1y plus 2y is 3y. And then 2 plus 10 is 12. So now we've got to solve for y. I'm going to divide by 3. So y is equal to 4. So my point there is 4. So now we're going to go through. I've solved for y. That's 3/4 of the problem. I'm done. So now I got this little part left. And I look, which one of my two equations should I use, this top equation or should I use the bottom equation to solve? It doesn't matter. So I like the one with just x has no number. That's why I pick it. So there's the leading coefficient, or the coefficient in front of x is 1. That's why I like it. You could use the other one and you'll get the same answer. It's totally fine. Minus 2 times 4 equals negative 5. So 2 times 4 is 8. And a negative times a positive gives you that negative 8 equals negative 5. And then we go through and we're going to add 8 to both sides. So those cancel out. So x is equal to negative 5 plus 8. And this ends up being 3. And then this is for the first part of elimination. These are your notes for the first part of your assignment.